Okay, more past HSC 3D trigonometry problems. 2003, question 7A. David is in a life raft there, and Anna is in a cabin cruiser searching for him. They are in contact by mobile phone. David tells Anna that he can see Mount Hope, which is here. That's the top of Mount Hope. That's the base of Mount Hope. Of course, you can't see it, but he can see Mount Hope from his position on a bearing of 109 degrees. So in this case, I would say that the north has been drawn straight up and that this up to there is 109. Remember this, and the angle of elevation of the top of the mountain is 16. Do you sort of get the idea? This right angle triangle here with 16 degrees is sitting up in the air, and from David's position here, Mount Hope, remember bearings are measured along the ground, Mount Hope is on a bearing of 109 degrees. So that in blue is 109 degrees, but this 16 is an angle of elevation triangle in the air. And Anna can also see Mount Hope from her position, and the bearing of Mount Hope is 139. So that angle there is 139. Remember, bearings are measured on the ground, and that is the bottom. That's the ground of Mount Hope. And the angle of elevation of Mount Hope from Anna is 23 degrees. The diagram looks bad because north has been drawn upwards. If north is drawn oblique like this, it wouldn't look the way it looks, okay? But look, at least the bearings look like normal bearings. So what we're going to do, we're going to draw the three triangles separately. I think it would be the best thing for us to do. So what I'm going to do, this does not give us any guidance as well, and the angle of Mount Hope is 1,500 meters high, and it says find the distance and bearing of the light raft, this from Anna's position. So I'm going to draw the ground level triangle, and I'm also going to draw the two angle of elevation triangles. Now the two angle of elevation triangles are nice and easy. This is Anna, the top of Mount Hope, the base of Mount Hope. The angle of elevation is 23 degrees. Okay, that's the first angle of elevation triangle, and this is 1,500. The second angle of elevation triangle would be from David's angle of elevation to the top of Mount Hope. That's his angle of elevation triangle. Notice I've labelled. So this here, up here, is a right angle triangle, which I've drawn down here. This does sort of look like a right angle triangle. It's there. You can see the right angles there in the diagram. And now I'm going to draw the base level diagram. So on the ground, this is what I've got. It sort of looks, oh, actually that's not drawn very well. I'll draw it in a minute. I'll draw it in a minute. Okay, so these, I'm going to draw my angle of my base triangle in a minute, and I'll do it over here. I've got north, this is about 139. Sorry, that's meant to be a straight line. All right. And then this is also meant to be a straight line. Well, that one does look straight. I'll do them again. I'll do them again a bit later. I know what to do now. I shouldn't draw them underneath each other. One's further away, obviously. Okay? All right. It's asking for the distance and bearing of the life raft from Anna's position. Look, all right, I will draw it. Third time lucky down here. That's sort of what it looks like. Okay, so we've got Anna, we've got David. We know that this angle here, the one in there, is 109, and that this angle here is 139 degrees. Okay, that's what it looks like. So we've got AB and DB. We can come up with expressions for AB and DB from the angle of elevation triangles. Pretty much 99% of the time, you'll be coming up with expressions for... Remember, all bearings are on the ground, okay? So you will be coming up with expressions for AB and DB from the angle of elevation triangles, all right? So let's go back up to the angle of elevation triangles and find expressions for AB and DB. So what have we got? Tan of 23 degrees is 1,500 over AB. So therefore, AB equals 1,500 over tan 23. Or you can write it as 1,500 cot 23. And tan of 16 degrees, again, is 1,500 over the over dB. So dB equals 1500 divided by the tan of 16 degrees. Okay, so we've used the two angle of elevation triangles to find expressions for lengths on the ground. Now I have an expression for AB and I have an expression for DB. I have this bearing here and I have that bearing there. Let's just see if this is 139. I could work out this one. If I put another north sign here at B, I can work this out, can't I? And I can actually work out that. So I can work out this angle. Watching. Look at this, where I'm outlining there. Isn't this co-interior? This is what I've got. Look. I've got A here, I've got B here, I've got north, I've got 139. Isn't this 180 minus 139, which is 41? So that whole thing is 41. But then let's just look down here as well. And I've got DB, that's north, and that's north. This is 109. So tell me what this whole thing is. 71. Co-interior angles add up to. So that's 71. So this is what I've got, 71 and 41. Are you okay with that? So it's 30. 71 degrees minus 41 degrees is 30 degrees. So that's going to be, so here is 41 and the whole thing is 71. So the little bit there is 30. Okay, so I've got 30 in there. So what I'm going to do now, I'm going to draw the triangle again, not with bearings, but just with distances. And I've got DAB, I've got 30 degrees. AB is 1500. Can I call it 1500 cot 23? Because it's 1500 divided by tan 23. Are we okay? And so that's 1500 cot 23. And DB is 1500 cot 16 degrees. Okay? And this is 1500 cot 16 degrees. Can you see now? Two sides in the included angle. You can use cosine rule to find the distance and bearing of the life raft. We want the distance from D to A. We can do anything now that we've got two sides in the included angle. We can find the length of this side, and then we can also use the sine rule to find one of the other angles. Sine theta on whatever equals sine whatever on whatever. Okay? So can we find AD? Angle of elevation triangles, separately drawn. Base level diagram drawn. The bearings always come into play with the base level diagram, the ground. Bearings are always on the ground. Angle of elevations are triangles up in the air, and the triangles up in the air, you just use them to find lengths, expressions for the lengths on the ground in your base triangle. Okay? If you just keep that in mind, you'll know what to do. All right, so let's go. AD squared equals, what have we got? That squared equals, isn't it, 1500 squared cot squared 23 plus, so it's this squared equals that squared plus that squared, 1500, sorry, I don't have enough room, 1500 squared cot squared 16 minus 1500 cot 23 times 1500 cot 16 degrees times the cos of 30. Minus 2AB cos C, or whatever it is. Yeah. We okay? This squared plus this squared minus 2 times that times the cos of that. And so AD squared is, and that can be just done on your calculator, but remember, so we don't want to write it as cot because you can't do it as cot on your calculator. You know, you could, 1500 squared is a common factor, so you don't have to enter it 3 times if you don't want to. It's up to you. But it is 1500 squared over tan squared 23. We could have kept it that way. Plus 1500 squared over tan squared 16, because that's how you're going to have to enter it on your calculator. Minus 1500 squared over tan 23, tan 16, and there is a cos 30 on the numerator as well. So that's what AD squared is. Good luck working it out. If you don't want to enter 1500 3 times squared, you could go 1500 squared bracket. But be careful. So you'll get an expression for that, and then you get that AD is whatever. Minus 2 times, I forgot the 2, minus, be careful and don't write it 3000, minus that, I'll just put the times 2 there on the end. Minus 2AB cos C. Girls, back over here, I wrote AB was that. I wrote it as cot, but then I decided to put it back as over tan to enter it into your calculator. Are you okay with that? I put it as cot here, but in hindsight, it's better to leave it as tan because you can't enter cot into the calculator. You've got to do it as over tan anyway. So if you want, you don't need that first row really. 2,000, I'm not going to write the AD squared in, 799 meters to the nearest meter. And now that we know that this is 2799, we need to calculate the bearing, the distance and bearing of the light raft from Anna. So we need the bearing of the light raft from Anna. So we need this angle in here, up the top. Because we know that this is 139 there. So we find theta and we can add the theta onto the 139, okay? So we have to find theta using this time the sine rule. Now I'd be coming up with, so we've got sine theta, are we ready? So sine theta over, I'm not going to write it as 1500 cot, I'm going to write it as 1500 over tan 16 degrees, is that okay? Instead of cot, equals sine of 30 degrees over 2799. Are we good? So sine theta, sine 30 is a half, 0.5 times 1500 over tan 16 degrees divided by 2799. So sine theta equals sine 30 times 1500 over tan 16 degrees divided by 2799. And so you can come up with an expression for sine theta and then an expression and work out what theta is. So work out what this is, press equals and then divide by 2799. So therefore, so we've got 69 degrees or 180 minus 69 degrees because now we need to, just by looking at the diagram, it does look like it's going to be an obtuse angle, so we can't rule that out yet. To be absolutely sure, so if you look at the diagram, it looks like, remember sine theta is positive in quadrants 1 and 2, so it could be acute or obtuse. Now if it's, what's 180 minus 69? 111. So let's just have a look at the diagram. The only way you could be absolutely sure is we know that this is definitely an acute angle, this one, just by looking at the bearings and stuff like that. And this is only 30 degrees and this is acute, and this does not look like anything more than 60. So this is more than likely going to be the obtuse one. But the only way you could be absolutely sure is to work out the angle at D. We know that one's going to be acute because of the bearings. Like it's not going to be that much, that angle in there. All right, so you could work that out. So the other thing is you could, instead of working this one out up here, you could work this out and do 180 minus, because this one is definitely acute because of the bearings. If this is a bearing of 109, this angle is definitely acute because you've got this angle here as well. That's not going to be, there's no way this here is going to be more than 90. All right, so this could be about 40 or 50 or something. All right, so I think we do find that this is acute, so this is going to be the obtuse angle. All right, so we're going for 111, but we would have to maybe double check. Maybe next time, if that looks obtuse, find the acute one and then do 180 minus to find that one. Okay, all right, and so therefore the bearing is going to be, if we look at the diagram, 139 plus 111, and that actually makes sense with where this is sticking out roughly. So the bearing is 139 plus 111, which is 250 degrees. So bearing's that, and the distance is 2799. Okay, but like I said, to be sure, you'd find the other angle. And 4 HSC, question 3D. So we've got a cube here, so it's got all equal sides, okay? 90-degree angles in the corner. The length of each edge of this cube, A, B, C, D, E, F, G, H, is 2 meters. A circle is drawn on the face, a flat circle, A, B, C, D, so that it touches all 4 edges of the face. The center of the circle is at O, and the diagonal AC meets the circle at X and Y. Okay? And the first question is explain why angle FAC is 60 degrees. It's worth 1 mark. All right, well, explain. What have you got up the top? What's the top face? It's a square, isn't it? What do you know about the diagonals of a square? Look, we might be able to find side lengths. 60 degrees, I think we're going to have to maybe use some trigonometry. Hopefully we'll get tan of root 3. Tan of 60 degrees is root 3. So let's get some side lengths, please. We know that the side lengths of the, let's look at, if we've got to find this angle FAC, this one, let's, do we have a right angle triangle somewhere to be able to use trigonometry or anything like that? Or we might just have an equilateral triangle somewhere. That's the other thing. Equilateral triangles have angles of 60 degrees. So why don't we find this length? And isn't this just another diagonal as well? Isn't FA a diagonal of the top square? And isn't AC the diagonal of square ABCD? And then if I finished the triangle, the equilateral triangle up, isn't FC also a diagonal? AFC, FC, AC, and AF are all diagonals of squares, and they're all the same length, and so therefore all the angles are 60 degrees. It says explain. So let's go that AF is the diagonal of square AEFB, and AC is the diagonal of the square ABCD, and FC is the diagonal of the square FGCB. Now all those diagonals are equal, right? All 3 squares are identical because they are faces of a cube. So therefore AF equals AC equals FC. Are we okay with that? And so therefore triangle FAC is an equilateral triangle. So the reason we couldn't use trig is I couldn't see a right angle triangle in that triangle. It's not right angled. I can't use trig. I was looking for a right angle somewhere. Look, I probably could have, yeah, but I want this angle FAC. That is not a right angle triangle.
Isn't FOA 90 degrees?
Yes.
You can make like in triangle OAF.
Yeah, you probably could, yes. Yeah, actually that's another way of doing it. This is another way. Actually, let's do it that way too. And so therefore angle FAC is 60. Very good to see that. The other thing is, so first way to do it is to say that all the diagonals are the same. And they are. Because look, angle FAC belongs in triangle FAC. We've just looked at the lengths of FA, AC and FC and they're all equal. The triangle's equilateral. So the angle is 60 degrees. Another thing we can look at is to look at, someone was saying, let's look at FO. Well, it's saying show that FO is root 6 meters. So they're using that in the next in the next bit. The next one's only worth 1 mark as well. We know that AF is the diagonal and these side lengths are 2. So we can work out AF. We know that AC equals AF, so OA would be half. So we can come up with an expression for OA and use Pythagoras' theorem, shorter side, to come up with an expression for FO, but we have to now state that YFO, does it say anything like that? YFO is perpendicular to AC. It doesn't mention that, or no? So if I join FC, okay, we know that FAC is an equilateral triangle. If I draw a line, we know that O is the center of AC. I know that FAC is equilateral. If you fold an equilateral triangle in half, you have symmetry. You have line symmetry. So I know that this equals that. This is and the bottom as well. But this is an equilateral triangle. If I fold it, I know that this length equals this one by symmetry. All right? So I'm going to start writing that out. And I'm going to move down. So part 2, we know that as we know before, AF equals AC equals FC. Let's find the length of AF. So let's just use let's say triangle ABF, for example. AF squared is AB squared plus BF squared. It's just using that top triangle, that's all. I'm using the top face, AEFB. We know that's 2 and that's 2. So AF squared is 2 squared plus 2 squared. AF squared is 8. So what's AF? No, it's root 8, which is 2 root 2. It's root 4 times root 2, which is 2 root 2. Now, we know that AF equals AC, and we know that O is the center of that circle, and we know that AO would equal OC. O is the center of that circle, and because the circle touches all the 4 sides of that square, I'm going to go, so therefore AO equals OC, and so therefore AO would be 2 root 2 divided by 2, because it's AF over 2. It's half of AF. We okay? So therefore it would be root 2. That's what AO is. And then we can work in triangle AOF. And we're trying to come up with an expression for OF. And we know that this is root 2 and this is 2 root 2. Or you can even leave it as root 8 if you want. So OF squared is 2 root 2 squared minus root 2 squared. So it's 4 times 2. It's 8 minus 2. So OF is the square root of 6. Just find the size of angle XYF. So I'm going to draw a pink line here. Now XYF is the same as the size of angle OYF, which probably is a better one to do because I know I've got a right-angled triangle here. I know the length of OF. I don't know the length of FY, but maybe I can find the length of, what's the length of OY actually? It's 1. Because if AB is 2, then if you go across here, from the radius of the circle is 1. So OY is the radius of the circle. Can you see that? So that's 1. OY is 1. So, and you know that by going like this, AB is 2, across there's 2, the radius is 1, OY is 1. So OY equals OX, which equals 1. Okay? So we know that, so from part 3, we know that XY equals the radius of the circle, which equals 2. The radius of the circle is 2. Because the reason is that xy equals the length of AB. So therefore the radius OX equals OY, which equals 1. Yeah, diameter. Sorry everyone, the diameter of the circle is 2, and so therefore the radii OX equals OY, which equals 1. You know what I meant. So we've got our right angle triangle here. OFY, that's 1. We know OF is root 6 from part 2. And we know that X is sitting along here somewhere. So angle they want angle XFY. It's going to be twice angle FOFY, isn't it? Sorry, go back up. We need angle XFY. Why don't we find angle OFY and double it? Oh no, I think I was pointing to the wrong angle before. Do you get that? The angle XFY is equal to 2 times angle OFY. All right? So let's find angle. So angle FXY is equal to 2 times angle OFY. So we're going to find angle OFY first. So what are we going to use? Sine, cos, or tan for this? No? Yes, we're going to do tan. Tan of theta is 1 on root 6. Theta is, and then angle FXY equals 2 times theta, which is, so I think I was pointing to the wrong angle before. I was doing XYF instead of XFY. So, as I've got over here, if you want angle XFY, it's 2 times angle OFY. Are we okay with that? So what do you get? Shift tan of 1 on root 6. For, but do not round it. And now times by 2. And I'd be writing the seconds. Actually, you know what I would do here? I wouldn't do it like that. I'd just go 22 point whatever degrees. Don't put it in degrees, minutes there. And just don't round it. So 22.207 ... degrees. And 2 times that, which is 44.414 whatever degrees, which is, now you can just do it to the nearest degree, 44 degrees. Okay? HSC question 5A, a boat is sailing due north from a point A towards point P on the short line. So it's sailing, a boat is sailing north from A to P. Let's look at the diagram. See, it's sailing from A, this is where the boat's going, along the pink line. From A to P, and see how there's a north sign there? That is due north. That means that A is south of P. So the boat's going along there, due north, towards P. This is the shore line, and the boat's heading is going towards shore. Okay? The shore line runs from east to west. Okay? And this is north. In other words, this is a right angle here. And they've put the right angle in the diagram. Doesn't look like a right angle, but why do we draw it sideways, north? So that you can get your angle of elevation triangle in. Otherwise, you're not going to get it in. You won't be able to draw it. Okay? So in the diagram, T represents a tree on a cliff vertically above P. And L represents a landmark on the shore, 1 kilometre, obviously to the east of P. So, and the distance PL is 1 kilometre. Okay. From A, the point L, now we're on the ground. So we've got this triangle here is an angle of elevation triangle. So is this one here. But the bearings are always drawn on the ground. So from A, the point L is on a bearing of, so here's north, guys, here's north, the pink line. Aren't bearings measured from north? So this angle in here is drawn on the ground, it's 20 degrees, because the bearing of L from A is 20 degrees. And the angle of elevation, so this one is up in the air, the other triangle. The angle of elevation of T from A to T is 3 degrees. This one here is up in the air. It's 3 degrees. This other one is on the ground. So it'd be really good to draw a ground level triangle. Angle of elevation triangle is really good now too, because you can come up with a distance for AP. Remember, what do you use your angle of elevation triangles for? To work out distances on the ground. Okay, now I don't know the height. I don't know the height. Do we know the height? We know that this is 1 kilometre. We don't know the height of the tree yet. So then it says, after sailing for some time, the boat reaches a point B, so the boat's coming along here, and the angle of elevation to T, to the top of T, is 30 degrees. So this as well is an angle of elevation triangle. All right, so we've got 3 degrees here, 30 degrees there. Now the question is, show that this distance BP, first part, show that BP is root 3 tan 3 over tan 20. Okay. Well, you know what? You've got to do something with tan 3 and you've got to do something with tan 20, don't you? Now, tan 20 is the ground level diagram. What would, if this is a right angle here, so I'm actually going to do this one a little bit on the sheet. So we've got this ground level triangle. I can come up with AP. Okay, we have to come up with an expression for BP. Isn't BP well, we need tan 20, so we're going to use this other one here. Isn't BP AP minus AB? But I don't know what, we'll just see what we're going to do with that. I don't think we can do anything with it yet. We'll see. We might be able to. Because if that's 30, anyway, we'll see. Right, what have we got here? What's tan of... Anyone? Oh yeah, we can come up with 2 expressions for AP. I can come up with an expression for AP in the top triangle, and I can come up with an expression for it in the bottom triangle. See how AP is common to my angle of elevation triangle and to my ground level triangle? So let's just try that. So let's go tan of 20 degrees is 1 over AP, which means that AP equals 1 over tan 20. I mean, this is worth 3 marks, so there's going to be a bit of work there. So this is part 1 working. All right, let's use this other triangle as well to get an expression for, but the problem is it's got TP in it. Well, let's try. So then we're going to work in the angle of elevation triangle. And we've got TPA, this is 3 degrees. Sorry, 3 degrees. You see what I'm doing? I can come up with an expression for AP there. What would this be? Tan of 3 degrees is TP over AP. So AP is TP over tan 3. But, okay, maybe we can come up with an expression for, all right, so we've got an 2 expressions for AP. So that means, we can come up with an expression for TP now. Because the 2 APs are equal to each other, see what we're doing? I've got an expression for AP here, and I've got an expression for AP here. So can't I put them equal to each other and come up with an expression for TP? So therefore, so I'm going to go equation 1, equation 2, solving 1 and 2 simultaneously. We get that 1 over tan 20 equals TP over tan 3. We're still not done, but we're getting there. In other words, TP equals tan of 3 degrees over tan of 20 degrees. Now, let's draw, we have to come up with an expression for BP. So let's draw the BP triangle. You know, the BPT triangle. So now, how did we know what to do? You look at what you're trying to get. Tan of 3 degrees tells you I have to use this big triangle. Have to. Tan of 20 degrees tells me I need to use this big triangle. You notice in those two triangles that AP seems to be common. So maybe if you come up with an expression for AP in both triangles, the APs, you'll lose them and you'll end up with the expression for TP. Now, let's go back to this triangle. We need BP. BP, you have to be working in this other triangle to get it. So so we're going to draw a triangle BPT. So I'm going to draw now triangle BPT. If this is an angle of elevation triangle, this has to be a right angle. And this is 30 degrees. I know that TP, I've got an expression for it. It's tan of 3 over tan of 20. So now I can just come up with an expression for, so in now triangle TBP, I can do the tan of 30 degrees is opposite over adjacent equals tan of 3 over tan of 20 divided by BP. So doesn't therefore BP, so it's that divided by BP. So BP equals tan of 3. I'm going to write, what's tan of 30? Oh, it's all right. Over tan of 20. Isn't it divided by 1 on root 3? So it's, so I've got that. So I'm swapping BP and tan 30. Now tan 30 is 1 on root 3. Are you okay with me doing it like that? So dividing by 1 on root 3, isn't that multiplying by root 3 on 1? So that is tan 3 over tan of 20 times root 3 over 1, which is, so that is tan 30. All right? Here, I'll write it here. Tan 30 is 1 on root 3. And so therefore you've got your answer, root 3 tan 3 over tan 20. AB equals AP minus BP. AB equals AP minus BP. We've just come up with an expression for BP, and from part 1 in our working, there are 2 expressions for AP, but you would use the one without the unknowns. You would use the 1 over tan 20, wouldn't you? So it's 1 over tan 20 minus the expression we just got for BP, which is root 3 tan 3 over tan 20. So basically it's 1 minus root 3 tan 3 over tan 20. So I can write it with a common denominator, 1 minus root 3 tan 3 degrees over tan of 20 degrees, and that gives you your expression for AB. That's the exact answer, as long as you've written it. If you then proceed to work it out, that's fine, but just make sure you've got an exact answer there somewhere. So that's approximately 2.5 kilometres.